we have light, right, of a certain wavelength incident on the surface area as completely absorbed by the surface. We know the rate of photons arriving is n. So what is the pressure, okay, exerted on the surface by the light? So this is actually something we call radiation pressure. Why is there a pressure? Because, right, light actually exerts a force on the surface area that is shining on. And one step back again, why is there a force? It's because there is a change in momentum of the photons when they hit the wall. Okay, so that is actually the picture here. So we have many photons, right, arriving per unit time. So let's consider, right, just one of them. The initial momentum, right, is how much? Is equals to h over lambda, because the Bragg equation, right, works both ways. You use lambda equals to h over p for what? Okay, this for electrons or other particles. So you use this equation to find its wavelength. But for photons, right, you will actually use p equals to h over lambda to find its momentum. Okay, so this photon, right, is absorbed by the wall. That means, right, it doesn't come out already. Therefore, what is the final momentum? 0. Okay, so if you consider, right, change in momentum for one photon, that will be equals to the magnitude, right, will be equals to h over lambda. Okay, so we want to find the average force. Average force, right, will be the total change in momentum divided by time. One photon changed by h over lambda, and there are n photons per unit time. So this average force, right, will work out to be nh over lambda. Finally, you want to find the pressure exerted on the surface. So pressure equals to force divided by area, okay, which is S. So it's nh over lambda S. Option D.